Good morning and once again welcome to my YouTube channel, Pearson at Excel International Maths by Mr. Kamoto. And today I want us to introduce ourselves to logarithms, and we'll be looking at Pure Mathematics 2, page 52, and the 3.2, whereby we are told the inverses of exponential functions are called logarithms. The inverses of exponential functions are called logarithm. That is a very, very important statement. We're going to see how these inverses are turned to logarithms. The inverses of exponential functions are called logarithms. A relationship which is expressed using, it's important to write that the inverses of exponentials, the inverses of exponential function, the inverses of exponential functions are called logarithms. Uh, and of course, every time you're talking about the inverses of exponentials, it is important to think of what I majorly call the anti-clockwise movement. For example, if log to base a of n is equals to x, this one is a logarithmic notation. If I want to write this one in the index notation, I always talk about anti-clockwise movement, which gives me that a raised to power x is equals to n. Of course, this is logarithmic notation, this is index notation. You would clearly see that this is an exponential function and this is a logarithmic notation. So the inverse of this is this. Of course, it goes without saying, and I would want to repeat this in a more clear way and say the logarithm into base 10 as we know it of 100, if you may use your calculator, you realize this is simply a 2. If you would want to confirm this using the index notation, you would again employ the anti-clockwise movement and say 10 raised to power 2 is equals to 100. And these two statements are true. So therefore, this is logarithmic notation and this is index notation, where both of them are true. And that is just what I would want everybody to remember. If you look at example 3, we are saying write each statement in logarithm. Write in logarithms. And the first statement is 3 raised to power 2, which is 9. Again, I should have said that when you are having a logarithm notation, desiring to write it in the index notation, what you do is you apply the anti-clockwise movement. If you have the index notation and you want to write it in logarithmic notation, again, you apply the anti-clockwise movement and say the log to base 10 of 100 is 2. The log to base 10 of 100 is 2. Just like we said, this one is the log to base 10 of 100 is 2. Just like we said, 2 or rather 10 squared is equals to 100. So that is just like it. And again, you simply employ anti-clockwise movement and have it like the log to base 3 of 9 is simply 2. And that is what we have. If you look at the other one, which is part A, and there is part B of the same, 2 raised to power 7 to 2 raised to power 7 is equals to 128. I don't know whether this is true, but of course you know the first one was true. 2 raised to power 7 is equals to 120, which is very correct. So if you want to write this one now in the logarithmic notation, anti-clockwise movement, we start here and talk about log to base 2 of 128 is equals to 7. It's as simple as that. And the last one, C, 64 raised to power a half is equals to 8, which we know that the root of 64 is half. Writing this one in logarithmic notation, we talk about the log to base 64 of 8 is equals to a half. The log to base 64 of 8 is equals to a half. And that is as simple as that. In the same video, I would want to express example or to explain example 4 so that because the idea is the same, we are told that to rewrite each statement using a power. So we are now going to move from logarithmic notation because part A is log to base 3 of 81 is equals to 4. Again, anti-clockwise movement indicates that 3 raised to power 4 is equals to 81. And it's as simple as that. Part B, we are having log to base 2 of 1/8 is equals to -3. And this is very true. So in the index notation, we talk about again anti-clockwise movement, which gives us that 2 raised to power -3 is equals to 1/8, which is perfectly mathematically correct. If I may want to express, or rather to explain example 5 in the same video, I would simply say, without using a calculator, find the values of, without using calculator, find the values of A, the logarithm into base 3 of 81. And it is very important for us to note that the logarithm into base 3 of 81 is going to be something, let's call it x, yeah, because we are looking for the value. If we desire to write this one in the logarithmic index notation, we are simply going to apply the anti-clockwise movement and say 3 raised to power x is equals to 81. And further, we can talk about 3 raised to power x is equals to 81 into base 3 is simply 3 raised to power 4. And obviously, you can already see that x is equals to 4. That is part A. Part B, we are having the logarithm to base 4 of 0.25. And if you want peace, we would rather write this one in a fraction form, which gives us the logarithm to base 4 is of 1/4 is equals to, let's say, x. Again, if you apply the anti-clockwise movement, is going to give us 4 raised to power x is a quarter. And of course, this one is 4 raised to power -1, which tells us 4 raised to power x is 4 raised to power -1. And it goes without saying that x is equals to -1. And at that particular point, we get the value of x. In part C, we are told that the log into base 5 of 4, let this be x again. Applying logarithmic notation, or rather the anti-clockwise movement, we have 5 raised to power x is equals to 4. And that 5 being equals to uh, 5 raised to power x is equals to 4, and definitely we are told that this is not 5, this is 0.5 into base 0.5. So this is 0.5, which is actually a half raised to power x is equals to 4. And it goes without saying, you can write all this into base 2 and say 2 raised to power minus x, because it gets up there to be minus 1 times x minus x is equals to 2 raised to power 2. So definitely you would see that our x is equals to negative 2. And that is it. Part D, the logarithm into base a of a raised to power 5 and this one is quite critical. You would be able to remember the law of indices, which says that if we're talking about log to base a of a raised to power b, this one is the same as b log to base a of a. So this index now becomes a coefficient, in the sense that we're going to have 5 log to base a of a. But we all know that log to base a of a is 1, which is, even if you employ your calculator to get log to base 10 of 10, it's 1. So this is 5 times 1, which is easily a 5. And that is the final submission, because we know very well that log to base a of a is equals to 1. That one must not be forgotten by anybody. And therefore, yes, that is it. I think we have been able to explain 3 examples in this video, and please subscribe to my channel and be on the lookout and share widely so that we can work together. All right.